All right. Okay, so good afternoon to everyone. Welcome to another episode of Moyo Math. I didn't realize my mic was muted. But today we are going to be looking at Algebra Part 3. With Algebra Part 3, we are focusing on three important topics. We're looking at quadratic equations, linear programming, distance, speed, and time graphs. Of course, our CSEC exam is in May of 2025, and we want to ensure that all topics are well understood, all topics are covered thoroughly, so when we enter that exam, we can enter comfortably and do an excellent paper. So don't forget to like, share, and subscribe to the channel. So let's look at some topics: quadratic equations, linear programming, speed, distance, and time graphs. So let's start with quadratic equations. So we want to solve the following quadratic equation using the method of factorization. So for us to solve using factorization, we have 2x squared minus 9x is equal to 0. This is a quadratic equation because we have variable squared makes it quadratic, an equal sign makes it a quadratic equation, and of course when the expression is equal to 0, we have all the requirements to help us to recognize it is a quadratic equation. So we want to solve this using the method of factorization. So of course it requires us to know how to factorize, and the method of factorization we're going to use here is the method of the highest common factor. So the highest common factor clearly is x. I take out x as my highest common factor, and I'm going to divide x into each term. So I'm going to divide x into 2x squared to give me 2x. And I'm going to divide x into negative 9x to give me negative 9 is equal to 0. Of course, in solving a quadratic equation, we're solving for two values of the unknown quantity. So we need to get two values of x. And we're going to get easily two values of x by simply stating the keywords either. I'm going to take my first factor x, place it equal to 0. So that's one solution of the quadratic equation. And I'm going to use the other keyword, which is or. I'm going to take 2x minus 9, the other factor, 2x minus 9, place it equal to 0. And then we solve for x, and so the 2x is equal to, I add 9 to both sides, and then I can divide both sides by 2. So x will be equal to 4.5 or 4.5. So my two solutions of x are 0 and 4.5. Let's move on to another question. So they want us again to factorize and solve this quadratic equation. Recognizing it is a quadratic equation, we have variable squared, we have an equal sign, we have the quadratic expression made equal to 0. But for part 1 of this question, they want us to factorize completely the expression 5x squared minus 9x plus 4. So let us factorize. So again, testing our knowledge of factorization and using the factors of the expression to help us to solve the quadratic equation in part 2. So we have part 1, 5x squared minus 9x plus 4. So let's factorize. We're going to use here the method of the quadratic expression. So I'm going to multiply a 5 by 4, a by c. Remember, when it's in this form, it's the quadratic expression, method of the quadratic expression we're going to use, and we're going to multiply a by c. So a will be 5, c will be 4. 5 by 4 will give us 20. Then we want two factors of 20. When multiplied will give us 20, but when added or subtracted can help us to get negative 9. So looking at two factors of 20, so two factors of positive 20 will be negative 5 by negative 4 will give us positive 20. But negative 5 attach x, negative 4 attach x. So negative 5x subtract 4x will give us our middle term, which is negative 9x. So I'm going to rewrite my expression I'm going to rewrite my expression as 5x squared, replacing negative 9x with negative 5x, subtract 4x plus 4. So I've moved from 3 terms to 4 terms, and what I'm going to do now is to further factorize. So I'm going to use the method of grouping, see that I have 1, 2, 3, 4 terms. So I'm going to split into 2 pairs. And what is common to my first pair? Clearly 5x. I divide 5x into 5x squared to give me x. I divide 5x into negative 5x to give me negative 1. So that's me factorizing my first pair. Let me factorize my second pair. Always remember the sign controlling the first term of the second pair we take out automatically. Then we're going to pull out what is common. What is common clearly will be 4. So negative 4 becomes our highest common factor. So I divide negative 4 into negative 4x to give me x. And I divide negative 4 into positive 4 to give me negative 1. I have the same expression in brackets, so I can further factorize by taking out x minus 1 as my common factor. And what remains, 5x and negative 4, will be placed in the other bracket. So this is me factorizing completely 5x squared minus 9x plus 4. That's part 1. Part 2, they want us to hence solve the quadratic equation. Now remember, when you solve a quadratic equation, you're solving for 2 values of the unknown quantity. So I'm taking the factors. So I'm solving this quadratic equation. Let me state the quadratic equation first. So I have 5x squared minus 9x plus 4 is equal to 0. I factorize the expression on the left in part 1. So you see the word hence. So I'm going to replace the expression with factors I got. Of course, maintain equal to 0. And let me solve to get my 2 values of x. I'm going to use my keywords, which are either x minus 1 is equal to 0, and therefore x is equal to 1, positive 1, that's one solution of x. Or I'm going to take 5x minus 4, place it equal to 0. 5x is equal to positive 4, and then I'm going to divide both sides by 5. X will be equal to 4/5. So my 2 values of x are x is equal to 1 and x is equal to 4/5. Solving our quadratic equation. Alright, let's move on to the next. So they want us to solve this quadratic equation, but this time we're using the method of the formula. Remember, all these questions are questions from the CSEC past papers. So we want to solve this quadratic equation, but we are using the method of the quadratic formula. So we have here x squared minus 60x plus 225 is equal to 0. So we're using the quadratic formula, and first we must know what is the quadratic formula. The quadratic formula, it is simply x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is your quadratic formula. And of course, we have to identify what is a, b, and c. A will be the number in front of x squared, which is 1. B is the number located in front of x, which is negative 60. And c is your constant, which is 225. So let's substitute all these values into our formula. This is x is equal to, I hold the subtraction sign in front of b. I'm going to replace b with negative 60, which I'm going to put in brackets, plus or minus the square root of b squared, that's negative 60 in brackets, squared, minus 4 times a, which is 1, I put 1 in brackets, and c, which is 225, I place that in brackets, all over 2 times a, I replace a with 1 in brackets. So let's further simplify. This will become a minus by a minus is a plus, so I'm going to get 60 plus or minus the square root of, so we're going to work out negative 60 all square, that's negative 60 by negative 60, which is positive 3,600, and we're going to multiply negative 4 by 1 by 225. So negative 4 times 1 times 225 will give us negative 900 all over 2. This will simplify to become x is equal to 60 plus or minus the square root of 3,600 minus 900 will give us 2,700 all over 2. So we define the square root of 2,700. So this will be second function, square root symbol 2,700. And I'm going to get here x is equal to 60 plus or minus 51.9615. And I would advise take about 4 places after the point because it will help you to get a better approximation to your answer. All over 2. And at this point, we're going to use our keywords. The keywords are either x is equal to 60, and I'm going to take, remember you're solving for 2 values of x, and so use it for plus or minus. So I'm taking 60 plus 51.9615. I'm going to divide that by 2. So this will give me x is equal to 60 plus 51.9615. That will give me 111.9615. Let me divide by 2. So I'm going to get 55.98. And what I will do, I will approximate my answer correct to 1 decimal place. So to 1 decimal place, I count 1 place after the point. I look at the number immediately after, which is 8. Now, most times, even though I'm approximating to 1 decimal place, most times in the CSEC exam, they ask you to approximate correct to 3 significant figures. So let's approximate correct to 3 significant figures. So it means I'm counting from the first non-zero digit from the left, 5. So I count 1, 2, 3. I look at the number immediately after, which is 8. Once it's 5 or more than 5, I add 1 to my number that is underlined. So that 9 now becomes 10. And 1 from my 10, I'm going to add to this 5 to become 6. And I'm going to replace that 9 with 0. So it's 56.0, correct to 3 significant figures. So SF stands for significant figures. And let's work out the OR part of it now. OR, I'm going to take 60, subtract, x is equal to 60, subtract 51.9615 divided by 2. So this will give us 60 subtract 51.9615. So this will give me 8.0385 divided by 2. When I divide by 2, I'm going to get 4.01925. And to 3 significant figures, I start from the first non-zero digit from the left. I'm counting from 4. So I count 1, 2, 3. I look at the number immediately after, which is 9. Once it's 5 or more than 5, I add 1 to my 1 to become 2. So this is 4.02 to 3 significant figures. Alright, so this is solving the quadratic equation using the method of the formula. So let's move on. Now, of course, under quadratic equations, we have to learn how to solve a pair of equations simultaneously. And those equations will be both linear and non-linear. Alright, and it will involve solving a quadratic equation to help you to achieve your result. So let's solve simultaneously the pair of equations. So this first equation, it is your non-linear, and the second will be your linear. So this is a non-linear. So we have, this is your non-linear. So non-linear equation, and this here is your linear equation. So let's solve the non-linear and linear equation simultaneously. It means that we're going to get two solutions, because the non-linear is normally a curve, the linear is a line, and they both will meet at a common point. So you're going to get two values of x and two corresponding values of y. So we expect to get 2 points of intersection. So we solve a pair of equations simultaneously. The objective is to get 2 points of intersection. Coordinates representing the points of intersection of the two equations. So let's solve it simultaneously. We have y squared plus 2y plus 11 is equal to x. So that's our non-linear. Our linear is x is equal to 5 subtract 3y. So when we solve a pair of equations simultaneously, the first thing we do is to label those equations. This is 1, this is 2, and we are going to use a method of substitution. So we're going to substitute using your linear, so focus on the linear. We see where x is already the subject, which is good. So what I'm going to do is to substitute my linear equation into my non-linear equation, which will allow me to establish a quadratic equation, which you're going to see now. So I am going to substitute equation 2, which is my linear, into equation 1, which is my non-linear. So where I see x in equation 1, I'm going to replace it with 5 minus 3y. So this will become y squared plus 2y plus 11 is equal to 5 minus 3y. So this is me substituting equation 2 into equation 1. And what we have here is a quadratic equation. So what we have to do now for a quadratic equation, we must have variables squared, we must have our equal sign, and of course the expression made equal to 0. So I'm going to take all that is on the right and bring it over to the left side of the equal sign. So this will be y squared plus 2y, negative 3y will come across as positive 3y, plus 11, positive 5 will come across to the left as negative 5 is equal to 0. So let's further simplify. This will be y squared plus 5y plus 11 subtract 5 will be 6 is equal to 0. And what we're going to do here is to solve this quadratic equation solve the quadratic equation by factorizing the expression on the left. So let's factorize this expression on the left. I'm going to multiply 1, which is on the surface of y squared, by 6, which will give me 6. And I want 2 factors of 6. When multiplied will give me positive 6. But when added or subtracted, it can help you to get the middle term plus 5y. And the 2 factors of 6 I'm going to use will be positive 3 by positive 2 will give me positive 6. But positive 3 attach y, positive 2 attach y will give me 5y. So my middle term achieved. And what we're going to do is to rewrite the expression on the left as y squared plus 3y plus 2y plus 6 is equal to 0. Solving simultaneously a linear and non-linear equation, alright? So I'm going to split my 4 terms on the left into 2 pairs. And let me factorize the first pair. I'm going to take out y. I divide y into y squared to give me y. I divide y into plus 3y to give me plus 3. I bring down my positive sign. I'm going to take out what is common to the second pair, which is 2. I divide plus 2 into plus 2y to give me y. I divide plus 2 into plus 6 to give me plus 3 is equal to 0. Then I can further factorize by taking out as a common factor y plus 3. And what remains, which is y plus 2, will be placed in the other bracket. So I have my 2 sets of factors that factorize the quadratic expression. And of course, I'm maintaining equal to 0. And at this point, I can say either, I'm going to say either y plus 3 is equal to 0, y is equal to negative 3, so that's one value of y, or y plus 2 is equal to 0, y is equal to negative 2, so that's my second value of y. So what I've found here are my 2 values of y, and each value of y will have a corresponding value of x. So we're going to get 2 points of intersection of our linear and non-linear equation, which is the objective, right? To solve for 2 points of intersection, coordinates of the points of intersection. So let us find our values of x for each, find corresponding values of x for each value of y. So I'm going to substitute. Y equal to negative 3 into my linear equation, which is equation 2, into equation 2. Equation 2, we have x is equal to 5 minus 3y. So where I see y in equation 2, I'm going to replace it with negative 3. So this becomes x is equal to 5 minus 3 times negative 3 brackets. This will be 5, x is equal to 5. Negative 3 by negative 3 is positive 9. And this will give us x is equal to 14. So our first point of intersection of our linear and non-linear, coordinates of the first point of intersection will be 14, negative 3. Alright, so that's one point of intersection, and we have the coordinates. Let us get a second point of intersection. So what am I going to do? I'm going to substitute x or y equal to negative 2 into my linear equation, into equation 2. So this will become so I'm going to substitute y equal to negative 2 into equation 2. Equation 2, we have x is equal to 5 subtract 3y. So where I see y, I'm going to replace y with negative 2. So x is equal to 5 minus 3 times negative 2 in brackets. X is equal to 5 plus 6, x is 11. So my second point of intersection will be 11, negative 2. So my solution will be 2 points of intersection, 1 point 14, negative 3, and the second point 11, negative 2. So let's move on to another question where quadratics will normally come into play. Alright, so with this question, Right, so this will lead us into a quadratic equation. So the first part of this question says, the diagram below shows a compound shape. So we have this compound shape. And this here is L, compound shape is L, M, N, P, Q, and R. The length of LR is x plus 3. The length of LM is 4x subtract 5. The length of MN is 3x. The length of PN is x plus 1. And they want us to find an expression in terms of x with the length of PQ. So they want us to find the length of PQ and the length of RQ. So let's find PQ1. So to get the length of PQ, which is this length here, well, simply we know that the length of MN it is 3x, and we know that the length of LR is x plus 3. So this here, if I create my rectangle, I know that this length from here to here is x plus 3. And of course, this is the entire length, MN, which is equal to 3x. So if I need to find PQ, it means I have to subtract x plus 3 from 3x. So therefore, PQ will be equal to 3x subtract x plus 3. And remember, because x plus 3 is an expression with two terms, I must put that expression in brackets. So we can't just write subtraction sign and x plus 3 after. We must put x plus 3 in brackets. Yeah? And what I'm going to do is to now remove my bracket. A minus by a plus is a minus, I have negative x. And a minus by a plus is a minus, I have negative 3. So this will simplify to become 2x minus 3. So I know that PQ is equal to 2x minus 3. So this is 2x minus 3. And they want us to now find RQ. So this is RQ here. So for me to find RQ, we know that the entire length of that rectangle will be 4x minus 5. And we know that this distance Pn, this is also x plus 1. And we know that the entire length it is 4x minus 5. So therefore, if I need to find RQ, I'm going to subtract x plus 1 from 4x minus 5. So therefore, part 2 or part B, this is one part A, one part B. RQ will be equal to 4x subtract 5. So the length of that's the length LM, right? So remember it's a rectangle, so the length from here to here will also be 4x subtract 5. Subtract, I'm going to subtract from that x plus 1, but because we have an expression with 2 or more terms, we must place that expression in brackets. Remember that. So this will be x plus 1 in brackets. Now let me remove my brackets and simplify. This will become 4x subtract 5, a minus by a plus is a minus, and again negative x. A minus by a plus is a minus, and negative 1. And I can group like terms, so this will be 4x subtract x and negative 5 subtract 1. 4x subtract x will give me 3x. And negative 5 subtract 1 will give me negative 6. So we know that RQ is equal to 3x subtract 6. This that distance RQ is equal to 3x subtract 6. So that's part 1. Let's look at part 2. So it says given that the total area of the shape is 414 centimeters squared, the total area, show that x squared plus x minus 72 is equal to 0. So these are questions that they are bringing in the CSEC exam regularly, and we want to ensure that we can utilize our knowledge to help us to show that the total area of the shape is x squared plus x minus 72 equal to 0 in that form, as a quadratic equation. So given the total area of the shape, it's 414 centimeters. So the shape is a compound shape comprising of 2 rectangles. So I've subdivided, I've drawn this dotted line here to separate it into 2 rectangles. This is one and this is another. So this is rectangle A and this is rectangle B. So we know that if I have to find the area of rectangle A, let me put on the shape here. So I've separated. This is A and that's B. We know that the length of A is 4x subtract 5. And we know that the width of A, this is the width of A, that will be x plus 3. So that's the width of A. So for B, we know that the length of B it is 2x minus 3. And we know that the width of B it is x plus 1. So what I'm going to do is to find the area of A, find the area of B, alright? And we're going to equate it to our 414 and simplify to get that expression, which is a quadratic expression, x squared plus x minus 72 equal to 0. So let's find the area of A. So area of A will be length by width, which will be 4x subtract 5 by x plus 3. And of course, we are going to expand. So this will be 4x by x will give me 4x squared. 4x by positive 3 will be positive 12x. Then I'm going to multiply negative 5 by x to give me negative 5x. And I'm going to multiply negative 5 by positive 3 to give me negative 15. And therefore, when we simplify, this will become 4x squared plus 7x minus 15. So that's the area of A. So we have found the area of A. Let us also find the area of B. So the area of B will be to multiply the length by the width. The length it is 2x minus 3 by x plus 1. So I'm going to expand again. This will be 2x by x will give me 2x squared. 2x by positive 1 is positive 2x. Negative 3 by x will be negative 3x. And negative 3 by positive 1 will give me negative 3. So when I simplify, we're going to get 2x squared, this is the area of B, minus x minus 3. So the total area of that compound shape, so the total area of your compound shape will be to add the area of A and the area of B. So that will be 4x squared plus 7x minus 15 plus, and that will be 2x squared. Of course, once you are adding an expression with 2 or more terms, it's important to place that expression in brackets. But we can get away with an addition sign. But let me put it in brackets so you know that we must place an expression with 2 or more terms in brackets. If we have an addition or subtraction sign in front of it, make sure you place the expression in brackets so you will not have any challenges when it comes to simplifying. So let's remove the brackets. So we become what? 4x squared plus 7x minus 15. Let me remove the brackets. Plus by 2x will give me plus 2x squared will give me plus 2x squared. Plus by negative x will be negative x. Plus by negative 3 will be negative 3. And this will now simplify to become 4x squared plus 2x squared will be 6x squared. Plus 7x, subtract x will be plus 6x. And we're going to have negative 15 subtract 3 will be negative 18. So this here is the area of that compound shape in terms of x. So we want to now show, given the total area of the shape is 414 centimeters squared, show that x squared plus x minus 72 is equal to 0. So in order for us to show that, this is what we're going to do. And let me erase here. We are going to place 6x squared plus 6x minus 18 equal to 414 centimeters squared. So this is the area of the compound shape as an expression in terms of x, and this is the area of the compound shape as a value. They're both the same, so we can equate. And what we're going to do is to take our 414, this is a quadratic equation. So I'm going to take my 414, bring it over on the left, and of course, I'm going to have my quadratic expression now equal to 0. So this will become 6x squared plus 6x and negative 18 subtract 414 will give us negative 432 is equal to 0. And therefore, to simplify that, I'm going to divide each term in that equation by 6. And let's see if we want to get x squared plus x minus 72 is equal to 0. So when I divide by 6, we're going to get here 6x squared divided by 6 plus 6x divided by 6 minus 432 divided by 6 is equal to 0 divided by 6. So 6x squared divided by 6 will give me x squared plus 6x divided by 6 will give me x, and negative 432 divided by 6 will give me yes. And I get negative 72, 0 divided by 6 is 0. So we want to ensure that we are familiar with questions as such where your knowledge of quadratics, yes, will come into play, but also understanding where we are given this compound shape and we have to be able to find the area of each shape and equate to the area in terms of a value and help them to simplify to achieve that quadratic equation given. Alright, so we want to ensure that we're familiar with questions as such. Okay, let's move on to the next. Right, so common type question you see in the exam, it is one where they ask you to complete the square, and they wanted to use completion of squares to determine what are the coordinates of the turning point, and what they will sometimes ask you to do is to sketch the quadratic function. So we want to ensure that we are clear how to treat with such. So first, we do want us to express 2x squared minus 3x plus 1 in the form a into x plus h all squared plus p. which is called the method of completion of squares. Now, there are different ways we can, convert the quadratic expression into that form. One approach I use, and students often find it to be pretty straightforward, would be the formula approach, where there's a formula for h, there's a formula for k. So, to start off, we are going to state what is a, which is the number in front of x squared 2, b, which is the number in front of x negative 3, c, which is your constant 1. Now, h is equal to b over 2a. That's the formula for h. b, it is negative 3 over 2 times a, which is 2. So I make sure I place 2 in brackets. So I'm going to get negative 3 all over 4. So h is equal to negative 3 over 4, negative 3 quarters. K, the formula for k, it is 4ac minus b squared all over 4a. So I'm going to replace, this is 4, I'm going to replace a with 2, I'm going to replace c with 1, all in brackets, subtract, I'm going to replace b with negative 3, so I'm going to place negative 3 in brackets squared, all over 4, and I'm going to replace a with 2 in brackets. This will become 4 by 2 is 8, 8 by 1 is 8, subtract. So we're not saying minus by minus is a plus, we have to hold the subtraction sign. We're going to square negative 3 to give us positive 9. Of course, then consider the subtraction sign in front of the bracket. So this will become negative 9 all over 8. So 8 subtract 9 will give us negative 1 all over 8. And that is your value of k. So having found a, h, and k, knowing a is 2, h of course is negative 3 quarters, k negative 1 over 8. You can say 2x squared minus 3x plus 1 in the form will be 2 open brackets x. I'm going to replace h with negative 3 quarters in brackets squared, and I'm going to replace k with negative 1 over 8. This is us converting the quadratic expression in the form a into x plus h whole squared plus k, where a, h, and k are real numbers, meaning they can be positive, they can be negative, they can be fractions, can be decimals. All right. Now they want us to use your answer from b above, which is what we got previously, to convert the expression into that form, to calculate the minimum value of 2x squared minus 3x plus 1 and the value of x for which the minimum occurs. Now, when they ask you to complete the square, this is normally a very common part to the question they will normally ask. So, let us determine the minimum value. So I'm erasing here. So we completed the square, we converted it into the form. So we have 2x squared minus 3x plus 1. And it has been converted into this form. So what they want us to do now is determine the minimum value. Now, remember the minimum value. This is a quadratic function, and what they want us to do is, remember a quadratic function is in the shape of a parabola. And every parabola will have a turning point. Now, the parabola will be shaped like this because the number in front of x, but it's positive. If the number in front of x squared was negative, then your curve would have been shaped like that. So we will have a minimum turning point, and therefore this minimum turning point will have an x coordinate and a corresponding y coordinate. So the y coordinate, we call it the minimum value, and the x coordinate will be the value of x for which the minimum occurs, otherwise known as the equation axis of symmetry. So completion of squares will help us to achieve both. So the minimum value, so part 1, the minimum value, it is always k when we complete the square. So k, and k in this case will be negative 1, so the minimum value, which is the y coordinate of the turning point, is k. So therefore, the minimum value y will be negative 1/8. Because negative 1/8, of course, will be the representation of k. And 2, the value of x for which the minimum occurred. So the value of x for which the minimum occurred, that is, x is equal to negative h. So that's the x coordinate of the turning point, negative h. So we know that x will be equal to all the subtraction sign, and we would replace h, we got h to be negative 3/4. So this will be negative 3/4 in bracket. So the x coordinate of the turning point will be positive 3/4. Yeah? So we have completed part 1 and part 2, and now let's look at the third part where I want us to sketch the graph of the function, clearly showing the coordinates of the minimum point, the value of the y-intercept, and the values of x where the graph cuts the x-axis. So they want us to sketch that function, so let's make sure we know how to sketch a quadratic function. So looking at here, sketching, and what I will do, let me create some space. In fact, what I will do, let me ensure that I have y is equal to minus 1/8 stated here, and x is equal to 3/4 stated here. Because we're going to use that to help us to sketch. So they want us to sketch that function. To sketch y is equal to 2x squared minus 3x plus 1. And remember, when you're asked to sketch, you're not going to place it on graph paper. It's a simple sketch in your book or exam paper and showing valuable information. The information we want to see are coordinates of the minimum point, so which we have. So the coordinates of the minimum point will be what we got in parts 1 and 2 previously. Yeah, so the x value of the minimum point will be 3/4. That's the x coordinate of the turning point, minimum point, and the y coordinate, which is the minimum value, is negative 1/8. So we have the coordinates of our minimum point. Then they want the value of the y-intercept. So the y-intercept, it is always c. So if you have a quadratic function, y is equal to ax squared plus bx plus c, the y-intercept is always c from the function. So in this case, our function, it is y is equal to 2x squared minus 3x plus 1. So c, the y-intercept, will be 1. So the y-intercept, c is equal to 1. So we have that value already. Now, they want us to determine the values of x where the graph cuts the x-axis. So, when the graph cuts the x-axis, of course, this here, the number in front of x, but it's positive, so it's a minimum turning point or a curve shape like this. And of course, it will cut the x-axis at 2 points, which are called your roots. So what we want to do is to determine what are the x coordinates, and from there we're able to sketch the function. So in order for us to get the values of x where the graph cuts the we have to solve a quadratic equation, meaning we're going to take the quadratic function x squared minus 3x plus 1 and put it equal to 0. Let's solve that quadratic equation so we can get our two values of x and then we can sketch the function. So in solving this quadratic equation, I'm going to multiply and factorize the expression on the left. So 2 by 1 will give me positive 2. And I want two factors of positive 2 when multiplied will give me positive 2. But when added or subtracted can help me to get the middle term, negative 3x. And the two factors of positive 2 will be negative 2 by negative 1 will give me positive 2. But negative 2 attach x and negative 1 attach x, that will give me negative 3x my middle term. So I'm going to rewrite the expression on the left as 2x squared minus 2x minus x plus 1 is equal to 0. I'm going to split now into two pairs. Let me factorize my first pair. I'm going to take out 2x. I'm going to divide 2x into 2x squared to give me x. I'm going to divide 2x into negative 2x to give me negative 1. Let me factorize my second pair. So the sign controlling the first term of the second pair I take out. And then, of course, there's nothing common to 1x and 1, but what is understood after this negative sign is 1. So I divide negative 1 into negative x will give me x. And negative 1 into positive 1 will give me negative 1 is equal to 0. Of course, x subtract 1 is common to both terms. I can take out x subtract 1 as my common factor, and 2x minus 1 will be placed in the other bracket is equal to 0. And I can comfortably say now either x minus 1 is equal to 0, x is 1, or 2x minus 1 is equal to 0, 2x is 1, x is a half. So what I will have here are the values of x where the graph cuts the x-axis. So let us sketch with all the information we have here. Let us sketch to show our quadratic function. So in sketching, we will have here our roots, which are x is equal to 1, x is a half. So I'm going to have 0. Let's assume that this is a half and that's 1. So that's what the graph will cut the x-axis. The graph will cut the y-axis, the y-intercept at 1. So remember, it's a sketch. It doesn't have to be accurately shown, but the key information must be placed on the sketch. And the minimum point will be 3/4. 3/4, of course, will lie halfway between a half and 1. 3/4 and negative 1/8. Let's assume negative 1/8 is somewhere here. So I have the coordinates of my turning point. That's what the curve turns. So we have our roots, which is negative a half and 1, and we have the y-intercept. So this is my curve. Passes through a half, negative a half, passes through a half, sorry. It turns at your turning point, 3/4, negative 1/8. And passes through the other root or the other value where the curve must cut the x-axis, which is 1, and this is a sketch of the function. So we have our roots, we have our y-intercept, and we have our coordinates of the turning point. Alright, so Right, let's look at the next type of question involving quadratics we can encounter. So they want us to copy and complete that table. So to complete the table is a simple case of substitution. So I will have my function y is equal to x squared minus 2x minus 3. And when x is negative 1, I'm going to replace y in the function, replace x in the function, sorry, with negative 1, so I can get the corresponding y coordinate. So this will be negative 1 in bracket squared minus 2 times negative 1 in bracket subtract 3. Negative 1 squared is positive 1. Negative 2 by negative 1 is positive 2 minus 3. And we get 3 minus 3, which is 0. So when x is negative 1, y is 0. And the second, when x is 2, what is y equal to? 2 in bracket squared minus 2 times 2 in bracket subtract 3. 2 squared will give us what? 4. Negative 2 by 2 is negative 4, subtract 3. 4 minus 4 is 0, subtract 3, which will give us negative 3. So when x is 2, y is negative 3. So having completed the table, they want us to now use a scale of 2 centimeters to represent 1 unit on the x-axis and 1 centimeter to represent 1 unit on the y-axis. Plot the points whose x and y values are recorded in the table and draw a smooth curve through your points. So, right, so this is our curve. So we set up our scale, we plot our points, and this is the curve we are expected to get. Alright? So 2 centimeters equal to 1 unit. Remember, 2 centimeters will be 10 subdivisions on the x-axis, 10 of those small boxes. From the origin, every 2 centimeters we increase by 1 unit. And on the y-axis, 1 centimeter equal to 1 unit. 1 centimeter will be 5 subdivisions on the y-axis. And when we plot, this is what we are going to get. This is our smooth curve. Alright? So that is what we're going to get when we plot those points on the graph page. Okay? And then they ask, right, so they state now, using your graph, estimate the value of y when x is equal to 3.5. Show on your graph how that value was obtained. So when x is 3.5, so 3.5 is here. That is between 3 and 4. So when x is 3.5, this is 3.5 here. What is the corresponding y coordinate? I'm going to draw a dotted line up to touch the curve, and then I'm going to come across to the y-axis. Alright? And for every subdivision on the y-axis, if 5 boxes is 1 unit, then 1 box will be 1 over 5 or 0.2 units. So if this is 2, then the box immediately after, that division immediately after will be 2.2. So when x, so to answer that question, when x is 3.5, what is the corresponding y coordinate? So we can part C is part A. So when x is 3.5, y is equal to 2.2. So the corresponding y coordinate will be 2.2. So simply you call that extrapolating, meaning you're moving from the x-axis to the corresponding y-axis, right? So when x is 3.5, we draw a line up, touch the curve, and travel across to the y-axis. So y is equal to 2.2. So part D, without further calculation, write the equation of axis of symmetry of the graph. What is the equation of axis of symmetry? The equation of the axis of symmetry is the x coordinate of the turning point. So this here it is this is 1, 2, 3, 4, -1, -2, -3. So the x coordinate of the turning point, or the equation of axis of symmetry, so looking at D part 1, so the equation of axis of symmetry will be, so if I draw a dotted line up, is going to meet the x-axis at 1, right? And of course, it will divide your graph into 2 equal parts. So therefore, the equation of axis of symmetry, or the x coordinate of the turning point, is equal to 1. And let's read the other part. Estimate the minimum value of the function y. So the minimum value it is simply the y coordinate of the turning point. This is -1, this is -2, -3, -4, -5. We have 1, 2, 3, 4, 5. So the minimum value, it is the y coordinate of the turning point. If I draw a dotted line across, you see where it's going to meet the y-axis at -4. So the minimum value is the y coordinate of the turning point. So you can say y is equal to -4. And let's look at state the values of the solution of the equation. So part 3, they want the values of the solution of the equation. So part 3, so the values of the solution of the equation. And the equation, it is x squared minus 2x minus 3 equal to 0. So the solution of the equation is simply where the curve cuts the x-axis, and that is a quadratic equation. And when we solve the quadratic equation via the graph, we look to see where the curve cuts the x-axis. So this equation can be broken up into the function y equal to 2x squared minus 3, and also y equal to 0. Y equal to 0 is your x-axis. Alright? And y equal to x squared minus 2x minus 3 is your quadratic curve. This is y is equal to x squared minus 2x minus 3. And where does the x-axis and the curve meet? They both meet that's a line y equal to 0, so which is the x-axis, and your curve meet at 2 points, here and here. So the solution of the equation will be x is equal to -1 and x x is equal to 3. So that's where the x-axis and the quadratic curve, they both meet at 2 points, and that will be the solution of the equation. Alright? Okay, let's move on now to linear programming. So linear programming. So the diagram below shows a graph of 3 lines and a shaded region. S is defined by 3 inequalities associated with the lines. The inequalities associated with the line y equal to 3. So this is y equal to 3 here. This is the line y equal to 3. And if we look, you have another line here. This is x equal to 2. And we have this line here. This is x plus y is equal to 10. And of course, this is your shaded region. So they want us to state, well, of course, the inequality associated with the line y equal to 3. This is y equal to 3. And the inequality, of course, is if we shade up, we shade above the line, then, of course, the inequality, because the inequality is represented by shading, the equation of the line is represented by, of course, an equation y equal to 3, but the inequality is represented by shading. So if we shade above the line, then clearly this means that for the line y equal to 3, the inequality is y is greater than or equal to 3 because we're shading above. Anytime we shade above, it's greater than or equal to. Alright? Now, they want us to state the other 2 inequalities which define the shaded region. So this is our shaded region. So what will be the other inequalities? We have the line here, x equal to 2, and in order for me to show where all 3 inequalities satisfies this region, for the line x equal to 2, I must shade to the right of the line x equal to 2, so it will satisfy the region. So the other 2 inequalities we can get. So the other 2 inequalities will be for x equal to 2, it's going to be x is greater than or equal to 2. That's one of the inequalities. And let's look at the other inequality. We have this line here, x plus y is equal to 10. Alright, we have that sloping line. It's a linear function. So hence it's a sloping line. And of course, for to satisfy this region, I must shade below the line. So linear programming will deal with inequalities and of course representing these inequalities on a graph. So for x plus y equal to 10 means that I'm shading below the line, and of course the inequality will be x plus y is less than or equal to 10. Because when I shade below a line that is sloping this way, it means less than or equal to. So let's quickly state here, if I have a line sloping that way, if I shade above, it means greater than or equal to. If I shade below, it means less than or equal to. If I have a line sloping this way, shading above, it means greater than or greater than or equal to, shaded below, it means less than or equal to. So shading below, of course, we will have, and if it's a solid line, we're going to use less than or equal to as opposed to less than. Less than, we're going to use a broken line as the equation of the line. But if it's a solid line, then we normally use less than or equal to or greater than or equal to. So in this case, we shade it below, so it's a less than or equal to. If we have a vertical line to the right, will be greater than or equal to, and if it's to the left, it's less than or equal to. If we have a horizontal line, well, as you see here, this is your vertical line, we've shaded to the right of that line, so hence the reason we have x is greater than or equal to 2. If we have a horizontal line, of course, if we shade above, it's greater than or equal to, and if we shade below, it is less than or equal to. Hence the reason we have the line y equal to 3 and we shade above, the inequality will be y is greater than or equal to 3. So these are the other two inequalities we can obtain from this graph and satisfying the shading region. Right, let's look at next. Right, so the other part of this question, it says the function p equal to, so you have part 2 of this question, the function p equal to 5x plus 2y minus 3 satisfy the solution set represented by the closed triangular region. So this is our closed triangular region here, right? This is the closed triangular region. And they want us to identify the 3 pairs of x and y values for which p has a maximum or minimum value. So they want us to identify the 3 pairs of x and y values. So the 3 pairs of x and y values will occur where we have to satisfy the regions, where all the inequalities coexist. And therefore the 3 satisfied regions will be here, here, where the 3 pairs of values for which p has a maximum or minimum value. 3 pairs of values we're going to focus on will be 3 vertices of the satisfied region, which is in the shape of a triangle. Good? So therefore, we can call one point A, we can call the other point B, we can call the other point C. So therefore, to answer this question, identify the 3 pairs of x and y values, so which p has a maximum or minimum value. So the 3 pairs of x and y values will be A, whose coordinates are 2 and 3. B, whose coordinates are 2 and 8. Right, so this is 0, 2, 4, 6, 8, 10. And C, whose coordinates, this is 2, 4, 6, 8, 10. So C, whose coordinates, this looks like 7, 3. Alright, so C lies halfway between 6 and 8. So we can add 7, 3. Yeah? So those are the 3 pairs of x and y values, so which p has a maximum or minimum value. And which of the pair of x and y values makes p a maximum? Alright, and we want us to justify our answer. And P is a maximum at what? So which of those x and y values make P a maximum? So for us to determine that, which of these x and y values make P a maximum, just simply substitute the x and y values into the expression they gave for P. So you know for that part of the question, which is part 3, when A is 2, 3, then P will be equal to what? Let me replace x with 2 plus 2, let me replace y with 3 minus 3, and therefore I'm going to get what? 10 plus 6 minus 3, which is 16 minus 3 to give me 13. And when B is 2, 8, we are going to get P is equal to 5 times 2 plus 2 times 8 minus 3. 5 by 2 is 10. 16 minus 3, that is 26 minus 3, which is 23. And when it's C7, 3, we're going to get P is equal to 5 times 7 plus 2 times 3 minus 3. 5 by 7 is 35 plus 6 minus 3. 35 plus 6 will give us 41 minus 3, which will give us 38. Alright? So, when they ask a question, which pair of x and y values make P a maximum, right? The pair of values which makes P a maximum will be C, which is 7, 3. Because the highest value when x is 7 and y is 3, we got a maximum of what? 38. Compared to B 2, 8 and A 2, 3. So therefore, the maximum value, which pair of values make P a maximum? So that will be, so the pair of values which makes P a maximum is 7, 3. Alright? Because we see 7, 3, when we substituted it into the expression given for P, we saw where 7, 3 gave us 13, which is the maximum compared to all other points that we substituted into P. And then they ask us, P is a maximum at what? So P is a maximum right, so P is a maximum at 38, which we saw. Alright? Because we substituted the point 73 to give us a maximum at 38. So the value of P will be 38, which we've calculated here. Alright? So let's move on to another. So linear programming Alright, so we have 3 equations represented by lines, and of course we have the satisfied region represented by inequalities. That's the shaded region. Let's highlight. We we have here the line x equal to 6. We have this line here. So this line is 3y is equal to x, and we have this line here. This is x plus y is equal to 10, equal to 40. And of course, this is the satisfied region. So the question says the diagram below shows the graphs of 3 lines, so 1, 2, 3, and the shaded region defined by the 3 inequalities associated with these lines. The inequality associated with the line y equal to 3y, equal to x is 3y greater than or equal to x. Now why is that the case? So we have 3y equal to x, the inequality is 3y is greater than or equal to x. And why is that the case? Because if we shade above, for a line that is sloping this way, shading above, this will be greater than or equal to or greater than. So in this case, once a line is solid, we use greater than or equal to. So 3y is greater than or equal to x. Okay? And they want us to state the other 2 inequalities, which is defined by the shaded region. So the other 2 inequalities will be, let's look here. This is x equal to 6, and this is my satisfied region, which means I have to shade this way. So if I have a vertical line shaded that way, this means what? Greater than or equal to or greater than, but because the reference line, the equation of the line is solid, we're going to use greater than or equal to. So the inequality here will be x is greater than or equal to 6. So that's one inequality. The other inequality, we have the sloping line here, which is x plus y is equal to 40. And in order for us to satisfy this region, it means we have to shade below the line. Good? And if you have a line sloping this way, and we're shading below, then this is less than or equal to, but because the reference line or the equation of the line is solid, we're going to write our inequality as x plus y is less than or equal to 40. So those are the other 2 inequalities we can derive from the information given on the diagram. And then it says now the function p, looking at part 2, is equal to 4x plus 3y. Right? The function p satisfies the solution set. This is the satisfied region represented by the closed triangular region. Identify 3 pairs of xy values for which p has a maximum or minimum. So first identify 3 pairs of xy values. Then it's simply a case to see where for a satisfied region, which is a triangle, looking at the coordinates of each vertex. One here, and one here. Right? So 3 pairs of xy values. This will be, of course, this is 0, 10, 20, 30, 40. So if 10 of these boxes, so 10 boxes is equal to 10 units, then one box will be 10 over 10, which is 1 unit. So you know that this will be 6. So looking at 6, and this is, right, this is like 6, 2. Yeah? So I'll call this point A, whose coordinates will be 6, 2. Alright, so they want us to identify 3 pairs of xy. The other will be b, and that will be 6. And you can put that at, this looks like 6, and this is 30. That can be about 634. So B, 6 on the x, 34 on the y, and C, this will be, we call that C. This will be 30. Right, that looks like about 3010. C 3010. So identify 3 pairs of x, y values, so which p has a maximum or minimum value. So those are your 3 pairs of x, y values where you're using the vertices of the satisfied region. And which pair of x, y values makes p a maximum? Justify your answer. So which makes p a maximum? We just need to simply substitute the vertices of the coordinates of the vertices of the satisfied region into our expression represented by p. And this will be what? This is p. Let's try a first. A whose coordinates are 6, 2. This is part 3. So A whose coordinates are 6, 2 will give us p as 4 times 6 plus 3 times 2, this is what? 24 plus 6, which is 30. And when it's B, 634, this will be P is equal to 4 times 6, 3 times 34, so 6 4s are 24. Plus 3 by 34 will be 102. So 24 plus 102 will give us 126. And C, which is 3010, this will give us P is equal to 4 times 30, 3 times 10, 4 by 30 to 120, 3 by 10 is 30, which will give us 150. So identify the 3 pairs of values which we did, and which pair of x, y values makes P a maximum. So clearly the pair of x, y values will be when x is 30 and y is 10, because we got a maximum of 150. So for part 3, so the pair which makes x, y maximum is 30, 10. Because we got 150 with the point 310 when we substitute it into our expression for P. Alright? Alright, let's look at another linear programming question here. Right, so the owner of a shop wishes to buy X guitars, so X guitars, and Y violins. Y will be violins. To satisfy the demands of his customers, the number of violins must be less than or equal to the number of guitars. Write an inequality to represent this information. So the number of violins, which is y, must be less than or equal to the number of guitars. So that's our first inequality. Straightforward. The cost of one guitar is 150 and the cost of one violin is 300. He has 4,500 to spend on the purchase of these instruments. Write an inequality to represent this information. So part 2. So the cost of one guitar is 150. Alright, and if you have X of them, then the cost of those X guitars will be 150 plus X. 150X, sorry. And if the cost of one violin is 300, you have Y violins, then the cost of those Y violins will be to multiply 300 by Y. And it says he has 4,000 to spend on the purchase, so the total cost of the instruments must not be more than 4,500, because that's the maximum amount he has to purchase. Right, the instruments. So therefore the inequality will be less than or equal to 4,500. So that's the inequality we're going to obtain for part 2. Part 3, of course, this inequality we can simplify. We can divide 150, can divide into everything here. 150 into 150, x is x. 150 into 300, y is 2y, is less than or equal to 150 into 4,500 will give us 30. So we simplify the inequality. Now, part 3. To get a good bargain, the owner of the shop must buy at least 5 violins. What at least 5 violins means? Violins will be y, so at least 5 will be y is greater than or equal to 5. Good? So we have our 3 inequalities. Now let's look at part B. This is part A. Using a scale of 2 centimeters on the horizontal axis to represent 5 guitars and 2 centimeters on the vertical axis to represent 5 violins, draw the graph of the lines associated with the 3 inequalities in A part 1, 2, and 3 above. So we want to draw lines associated. So we have here our first inequality. So our line will be y is equal to x. And if you have to draw that line, so when you are drawing, now this here of course it's y equal to x, so it's going to be a sloping line because it's of this form. But when the y-intercept, which is c, is 0, see there's no y-intercept, for us to draw that line, we have to set up a table. Alright? And the x coordinates will be using a scale of 2 centimeters on the horizontal axis to represent 5 guitars. We're going to start with 0, 5, 10, 15, 20. You can have a move up to 20. So when x is 0, this is supposed to draw this line y equal to x. Because there's no y-intercept, this is what we do. We set up our table, and of course we use the scale to help you to identify where we're going to start. And if the state here, 2 centimeters represent 5 guitars, then you start with 0, increase by 5, 10, 15, and so on. Right? So when x is 0, y is 0. When x is 5, y is 5. When x is 10, y is 10. When x is 15, y is 15. When x is 20, y is 20. So that's your first line. You'll be able to draw. And then the second, it is x plus 2y is less than or equal to 13. Alright, so this is the second inequality. So we can create an equation out of that by simply writing this as what? X plus 2y is equal to 30. Okay? And what we want to do is, again, this will be a sloping line because it's of the form y equal to mx plus c. And in this case, we will have a y-intercept. So all you need are 2 intercepts. You just need 2 points to draw this line. the x and the y intercepts. So what you're going to do is set up a nice little table. This is your x-intercept. This is your y-intercept. And to get the 2 points, which are the intercepts, to draw this line, what we're going to say, simply state, for the x-intercept, when a line cuts the x-axis, we automatically know that y is 0, and x will have some value. So when y is 0, we're going to substitute 0 into the equation of this line. So we're going to get x plus 2 times 0 is equal to 30, x plus 0 is equal to 30, x is 30. So therefore, you know the x-intercept, the coordinates will be 30, 0. The y-intercept, when a line cuts the y-axis, you know that x will be 0 and y will have some value. So when x is 0, we take the equation. I'm going to replace x with 0. I'm going to get 0 is equal to 0 plus 2y is equal to 30. 2y is equal to 30, and therefore y is 30 over 2, y is 15. So my second point, which is my y-intercept, will be when x is 0, y is 15. Good? So I have the coordinates to help me to plot my first line. I have my coordinates to help me to plot my second line. And the third line, of course, y is greater than or equal to 5. Right here. That line is simply y equal to 5. So that's my third. So let us represent those on the graph. Yeah, and then identify the satisfied region. So my line, let's take the first line, y is equal to x. I'm going to plot. So I have 0, 0, which is here. I'm going to have 5, 5, which is here. This is 5, 10, 15, 20, 25, 30, 35, 40, 45. Good? This is 5, 10, 15, 20, 25, 30, 35, 40, 45. So I'm going to plot my first point, which is 0, 0, 5, 5, 10, 10, 15, 15, 20, 20, 25, 25, 30, 30, 35, 35. Good? So this is my first line here, which is the line y equal to x. My second line, which is x plus 2y is equal to 30. All I need are the x and the y intercepts. The x-intercept is 30, 0, which is here. That's where it meets the x-axis. And the y-intercept is 0, 15, which is here. And all I'm going to do is to connect those 2 points to give me my line. Good, so this here is the second line, which is x plus 2y is equal to 30. And my third line, it is y equal to 5. So y equal to 5 will simply be a horizontal line passing through 5 on the y-axis. So this is my line y equal to 5, which is a horizontal line passing through 5. So therefore, let's represent inequalities. So if it is y is less than or equal to x, and let's make sure we read the other part of the question. It says, right, so draw lines, which we have done, and then shade the region in your graph that satisfy all three inequalities. So let's shade the region. So for the line y less than or equal to x, of course, once our line sloping this way, then less than or equal to will be the shade below. So I have a solid line, hence it's going to be less than or equal to and a shade below. Let's look at x plus 2y is less than or equal to 30. Again, once I have a line sloping this way, less than or equal to means I'm going to shade in that direction. So that is less than or equal to. So this is my line x plus 2y equal to 30. I'm going to shade below the line. And let's look at y is greater than or equal to 5. So if I have the line y equal to 5, which is a line sloping that way, greater than or equal to means I have to shade above. So I'm going to shade above. Good? And therefore, the region that satisfies all three inequalities will be this region. Alright, so that's a region satisfying all three inequalities. Okay? So if they ask us in the other part of the question, so shade the region that satisfies all three inequalities, we have shaded, and state the coordinates of the vertices of the shaded region. The vertices of the shaded region, this is part, right, B part 3, so this is B part 1. B part 2, we have shaded the vertices of shaded the satisfied region. And then B part 3, state the coordinates of the vertices of the shaded region. So B part 3, so the vertices of the satisfied region, this is a triangle. So let's call here A, let's call here B, let's call here C. So the vertices of A will be 5, 5. The vertices of B will be 10, 10. And the vertices of C, that will be 25. So we're looking at the satisfied region and the vertices of the satisfied region help us to make an informed decision. Alright, let's see. Right, the owner of the shop sells the instruments to make a profit of $60 on each guitar and $100 on each violin. Express a total profit in terms of X and Y and calculate the maximum profit. So they want the total profit in terms of X and Y. The owner of the store sells instruments to make a profit of $60 on each guitar. So therefore, the profit, if it's $60 on each guitar, a guitar is X, you have X of them, $60 on each guitar will be 60X. And $100 on each violin, good? You have Y violins, and it's $100 on each violin, so that would be 100Y. So the total profit will be 60X plus 100Y. That's an expression for the total profit. Okay? So they want an expression for the total profit. So this here is C part 1, So we have the expression for the total profit, and they want us to calculate the maximum profit. So how do we calculate the maximum profit? We are simply going to take the vertices of the satisfied region, the coordinates of the vertices, and let's see which one will give us the maximum profit. So the coordinates A, the maximum profit will be what? 60 times 5 plus 100 times 5. 60 times 5 will be what? 300. 100 times 5 is 500. So you're going to have 800. When it's B, which is 10, 10, you're going to get your profit as 60 times 10 plus 100 times 10. 60 times 10 will be 60. 600, sorry. And 100 times 10 will be 1,000. So that will be 1,600. And when it is 25, which is C, what we want to get? C 25, our profit will be 60 times 20 plus 100 times 5. 60 times 20 will be 1,200. And 100 times 5 will be 500. Which will give us 1,700. So the question asks, calculate the maximum profit. So the maximum profit clearly will be 1,700. So therefore the maximum profit is equal to 1,700. Yeah? So linear programming, representing inequalities on a graph, identifying the satisfied region, using the vertices of the satisfied region, tell us to make an informed decision whether we're going to make a maximum or minimum value based on what is asked in the question. Alright? Okay, so let's quickly look at distance time, speed time graphs. Alright, so let's look at distance time graphs. Now, the speed time graph below, not drawn on the scale, shows 3 stages of a journey of a car over a period of 40 minutes. Determine the acceleration of the car for each of the following stages of the journey. So stage 2. So this here is a speed time or velocity time graph. So you have here this is 12. This is our speed. This is 16, 0, 32, 40. So this is stage 2, stage 3, stage 1. So they want us to determine what is the acceleration. So of course, the acceleration at stage 2 will be 0. So stage 2, the acceleration is equal to 0 meters per second squared, right? Because at this point you're going to reach a maximum acceleration. So what will happen here? The acceleration will be 0, and this is known as constant velocity. Stage 3, determine the acceleration. So the acceleration is change in velocity v2 minus v1 over change in time t2 minus t1. So because we're looking at stage 3 and moving downwards, then this will be v1 and this will be v2. So we're moving downwards, we're starting here, so this will be the velocity v1, we're ending here, this is the velocity v2. And of course, if this is v1, then this will be t1. If this is v2, this is t2. So let's substitute into our formula. v2 is 0. Subtract v1, which is what? 12. Over t2, which is 40. Subtract t1, which is 32. So we get 0 minus 12 is negative 12. And 40 minus 32 will give us 8. So this is the same as this is negative 3. So negative 4, negative 3 all over 2. Right, so we have negative 1.5 or negative 1.5 meters per second squared. So that is the acceleration. Acceleration is change in velocity over change in time. Remember, acceleration is a vector quantity, so therefore the acceleration, which is known as, in this case, deceleration, negative acceleration, deceleration, will be a negative value. Just keep that in mind, right? A vector quantity can be positive, negative, or 0. In this case, the acceleration, negative acceleration or deceleration, is negative 1.5 meters per second. Alright, let's look at this here. Another. So we have another speed time graph or velocity time graph. Right, so they want us to calculate x. So during the first stage of the journey, the car increased its speed from 0 meters per second to 12 meters per second. So this is 0, this is 12, this is speed, meters per second. Of course, the speed time graph below, which do not draw the scale, shows the three-stage journey of a racing car over a period of 60 seconds. During the first stage of the journey, the car increased its speed from 0 meters per second to 12 meters per second in x seconds, right? Accelerating at 0.6, this is the acceleration, meters per second squared. So this represents the acceleration, first stage, right? Calculate x. So you know acceleration, this is part 1. Acceleration is change in velocity over change in time. And if we're moving this way, moving upwards, this is v1 and that's v2. And if this is v1, this will be t1, and if this is v2, V2, this will be T2. So let's substitute. V2 it is 12 minus V1 is 0 over T2 is X minus T1 is 0. And of course the acceleration is 0.6 meters per second squared. So this will be 0.6 is equal to 12 over X. And what we can do here is cross multiply. 0.6x is equal to 12. Tell us remove it from the fraction. And what are we going to get here? We're going to divide x will be equal to 12 divided by 0.6. And we're going to get x now as 12 divided by 0.6. We're going to get a time. Right, the value represented x, which is a time, that will be 20 seconds. Right, now what is the gradient of the graph through the second stage? Explain in 1 sentence what the car is doing at this stage. So, the gradient of the graph of this stage will be 0. Yeah? To have no gradient, and what's going to happen here, the car will be at will be moving at what you call constant speed. So for velocity time graph, right, during the second stage, what is the gradient? So the gradient, of course, will be the acceleration, which is 0. So the gradient, which is the acceleration, will be 0. And explain in 1 sentence what the car is doing at this stage. So the car is moving with constant velocity. So for a velocity time graph, that horizontal line represents constant velocity. Now they want a distance traveled by the car on the 3rd stage of the journey. So this is the 3rd stage of the journey. The distance traveled by the car. Anytime we deal with a velocity time graph, distance traveled will be the area under the figure. And the 3rd stage, we have to find the area under that figure, area of the triangle. So the distance traveled part 3 will be the area under that triangle, and we know the area of the triangle, it is base by height all over 2. The base, of course, will be 60 minus 25, which is 35. The height, of course, will be 12 divided by 2. So 2 into 2 is 1, 2 into 12 is 6, and 35 by 6 will give us 210 meters. Okay, and that will be the distance traveled by the car on the 3rd stage of the journey. Okay? Alright, let's look at. Right, so again, look at another speed time graph. So velocity time graph. So this velocity time, we're dealing with acceleration, constant velocity, deceleration. So using the graph, calculate the acceleration of the cyclist during the first 15 seconds. So this is the first 15 seconds here. So the acceleration, you know, will be change in velocity, part 1. Acceleration will be v2 minus v1 over t2 minus t1. So if you're dealing with acceleration, you have a right hand slope, then this is v1. This will be V2, this will be If this is V1, this is T1, and if this is V2, this is the corresponding time T2. So we know V2 is 40, subtract V1 is 0, over T2, which is 15, subtract V1, which is 0. So our acceleration during the first 15 seconds will be 40 divided by 15. We know 5 into 40 is 8, 5 into 15 is 3. So we know that the acceleration during the first 15 seconds will be 2 2/3 meters per second squared. Remember what's the unit of acceleration? Meters per second squared. Then the distance traveled by the cyclist during the period t equal to 15 and t equal to 35 seconds. This is 15 and 35. So the distance traveled we're looking at is this region here. We have to find the area under the figure. Alright? So in order for us to determine the distance traveled in a speed time or velocity time graph, the area under the figure will help us to determine the distance traveled. So let's get the distance traveled part 2. Distance traveled will be to find the area under that figure, which is a trapezium. Okay? So we know it is a trapezium. A trapezium standing up. A trapezium normally looks like this. But we put the stand up this time. So this is A and this is B, and this is the perpendicular height. So the same thing, we put the stand up, this is A, that's B, and that's your perpendicular height. And the area of a trapezium is a half times the sum of the two parallel sides by the perpendicular height. We have to find the area of the trapezium. Well, you can separate it into a triangle and a rectangle. Yeah? So this will be a half times A, which will be 40, plus B, which will be 50, multiplied by the perpendicular height, will be between 15 and 35, which is 20. So this is 90 times 2 to 2, 1, 2 to 20, 10. So that will give us 900 meters to the distance traveled. Alright? So remember, when it comes to speed time, the distance traveled is the area under the figure. Right, so let's look at now a distance time. So looking at a distance time here. Right, so we're going to have a distance time. So with a distance time, we know that this movement here represents speed, this here represents rest, and this here, of course, this represents speed towards something, forward movement. This is a rest, and this, of course, is your speed towards your original position, backward movement. Alright? Movement towards something, rest, and then you return to your original position. So what is the average speed during the first 2 hours? The first 2 hours here. So the average speed, part 1. So average speed. So remember, speed will be what? Change in distance, and if we're moving upwards right hand, so this is D1 and this is D2. And of course, if this is D1, this is T1. And if this is D2, that's T2. So it's going to be average speed D2 minus D1 over T2 minus T1. And D2 is what? 12 minus D1 is 0 over T2 is 2 minus T1 is 0. So So you're going to get 12 all over 2, which is 6 meters per second, with the average speed of the first 2 hours. Now, what did the athlete do during the period 2 and 3 hours after starting the journey? So 2 and 3 hours, which is here, right? So for a distance time graph, that horizontal line represents a rest. So for part 2, the athlete was at rest. So for a distance time graph, that horizontal line simply implies that the athlete was at rest between 2 and 3 hours. And what was the average speed on the return journey? So this is the average, this is the return journey here. And what is the average speed on the return journey? So the average speed, of course, will be your total distance over total time. So we do the same change in distance over change in time, and if we're moving downwards, this time we're moving downwards for a left-hand slope. This will be D1 and this will be D2. And if this is D1, then this is the corresponding time here will be T1. And if this is D2, then of course this is T2. So let's work it out. This is D2 minus D1 over T2 minus T1. D1 is 0. Subtract D1 is 12. Over T2 is 5. Subtract T1, which is 3.5. So we get negative 12 all over 1.5. And negative 12 divided by 1.5 will give us negative 8 meters per second. Right? Because remember the unit of speed, it's meters per second. But remember, and I want you to always keep this in mind when it comes to distance time, because distance is a scalar quantity. Alright? Distance speed, it's always positive. The result is always positive. So for the average speed on the return journey home, even though we worked out the average speed to be negative because it's a left-hand slope, we expect to get a negative result. We have to state the value as, or the result as a positive result. Because distance and speed, it is always positive when it comes to distance time graph. Speed, whether you're moving towards or you're returning, will always be positive. So therefore the speed, average speed, will be equal to 8 meters per second. So we state the result as a positive result. Alright? Okay, so this will bring us to the end of the session today. Please ensure that you like, share and subscribe to the channel. Make sure you look at the videos, use the videos to assist you to prepare for your examinations. Next week, again, we will be doing more work in preparation for the exam. I'll be focused on the geometrical component next week. So I hope you all will benefit from the video and what has been shared. And again, don't forget to like, share and subscribe. Alright? So take care everyone. See you in the next episode. Bye.